Hello all, welcome again. So in this second part we're going to have Ash here, so a round of applause please.
So hi everyone, I'm Ash Davies, I'm from the UK and I'm working in Berlin for a company called Immobilien Scout. This is a real estate platform in Germany. And I'm talking to you today about refactoring legacy code with Kotlin. There's a little bit of coroutines in there as well, so show of hands, who here is Android developer? Who here is not an Android developer? So there's a few people that are not either. Cool. So I was hoping that some of these topics were actually kind of applicable to both Kotlin Android developers and generic Kotlin developers, so hopefully you'll find it enjoyable. As well, at the bottom, there'll be the links to the Slido questions. So if you have any questions throughout the presentation, you can go check us out and then ask them there, and I will do my best to answer them at the end of the presentation. But no promises if I just come up with crap answers. Cool, so let's start off with a sort of definition of what is legacy code, or what is legacy. So you can define legacy code as code that's been superseded by another implementation, but yet is still in use, so therefore it is difficult to use and difficult to remove. So it's very difficult to replace. There's a really good book from Michael Feathers on working effectively with legacy code. And in this book, I really recommend you read it. It's not one of the type of books you read from front cover to back, but more as a reference, much like the clean code from Uncle Bob. But in this book, he sort of defines legacy code as code that is not tested, and that there's no kind of automatic regression testing, so that you can no longer have confidence in the stability of your code. And this means that, if you make changes, you cannot be guaranteed that you're not going to break something or have any regressions in there. So then that becomes legacy code that you can't rely upon. Click is a bit experimental. So you can't have can't have confidence in this. But I also like to include Java code in this, so I consider Java code to be legacy, because screw Java. So much of the content of this talk comes from the Android world, but I think it's applicable in a lot of situations as well. Hopefully it's applicable to generic platforms and back-end and front-end and whatever you might be using Kotlin. But more importantly, it's because as Android developers, we've sort of been stuck with Java for a very long time. And it's been about 10 years since since Android was actually first announced, and then since Kotlin has been announced as a first-class language. But since then we've always been using Java. But realistically, we've not really been using Java. We're using a sort of type of Java. Java's actually been out of our reach for a very long time, and that's because the JVM is not equal to the Android runtime environment, or the Dalvik environment. It's not the same. Now they share a lot of similar APIs, but it's not the same thing. This actually led to This actually led to a very other large company disputing the fact whether you can copyright API. You might not be able to see it from here, but this is a list of largest law firms by revenue, and the first is Oracle. I think this might have been doctored. I'm not sure if this is true, but it's quite hilarious. Anyway, so the Java that we're familiar with on Android is obviously Java 6 or Java 7. But there's a lot of features introduced in Java 8 that we always want to try and use as fast as we can. But these features have not really been made available to us until we started using the Android Gradle plugin version 3. And still many of the APIs are not available to us until minimum SDK version 24. So these are things like Lambda expressions, method references, default interfaces, and try with resources. And these all require using the Android SDK AGP version 3. Now this is fine because you can do it on your client side, but when you're working with parts of the API that need to be having a minimum SDK of 24, it's not so easy to achieve because you can't easily just update your users. You still have to kind of cater for a lot of users in developing markets perhaps who have older versions of Android. And things like this might include streams, for example. So you're not really easily able to raise the minimum SDK without just dropping support for a large portion of your user base. And it's not a very easy decision to make. So you have to get your managers involved, your investors involved, whatever. But it just means it's not easy to do. But this is actually only a concern if you're an Android developer. But what if you're a back-end developer? You can just use whatever version you like, sod it. Well, there's still actually a lot of other reasons to use Kotlin. There's many arguments to use Kotlin over Java, and a few of those things are like you have consistently familiar code, so you're using the same sort of idioms across the board that everyone is familiar with. Your code behaves idiomatically. Your code looks terse and concise. And the greatest thing about it is that it's actually being aggressively developed by the JetBrains team. So we're constantly getting new features and constantly getting bug fixes resolved in, well, quite fast times. So one of the key features that you're already probably aware of is the billion-dollar mistake, null. So null's plagued developers for a very long time. We've had to deal with nullability issues, whether something is null, whether they have framework code that returns nullable values, and it generally results in unpredictable behavior and unpredictable output, or polymorphic code. So you're probably familiar with something like this. And these very familiar null checks are littered everywhere in lots of different code bases. And, well, it's often referred to as defensive code. So defensive code is when you're sort of hardening your code base to not fail. So if something is null, you'll not perform an action. But the result of this is that you end up with polymorphic code with multiple different execution paths. So you're not really able to kind of reliably predict the behavior of your application because it might behave differently depending on the input. So the alternative to this is offensive code. That was a great slide. Accidentally skipped it. So the alternative to this is offensive code, and this is one of the sort of extreme code paradigms that's often thrown about, and I'll go into that now. Now, it's quite similar to defensive in a way, but the difference is that it doesn't tolerate errors. So you can't have errors in the wrong places. And if you've ever inspected an RX stack trace, you'll be familiar with this, that the error is being thrown somewhere and you have no idea where. And you really kind of can't figure it out easily. So it means that the point of failure is much easier to define and find out when you're bug fixing, because it happened when the unexpected input actually happened, or when the null input happened. And the second effect of this is the urgency of it. So if something in your production code is crashing because you're treating it as offensive, and you have to you assert that it's not null, or you assert that it's not matching the requirements you expect, then that crashes. And a crash is automatically, bad. We don't want our users to have crashing code. So it's treated as urgent, and you have a higher priority of this. And it's very easy to justify this to product managers or engineering managers when you say, hey, my app's crashing, I need to fix it. And you might have a period of a bit of instability, but if you apply this paradigm, you'll find that you end up with a much more stable code base and much less error prone and much more predictable. So how does this apply to Kotlin? And should we start using Kotlin? Well, the answer is clearly yes. You should already be starting using Kotlin. If you're not already, go and use Kotlin. Stop listening to me right now, go. So what does this mean for our little green robot friend? Well, like I said, Java has been the status quo for a long time. That is until, of course, as we heard from our esteemed colleague here, that Google I/O announced that Kotlin is primarily supported in 2018. This is the first class citizen in the world of Android. So in addition to Java and C++, it is one of the 3 primary supported languages. And then furthermore, we heard that it's not just a supported language, but it's the first supported language. So it's the go-to language that we're going to be developing in, and all the samples are going to be provided in it, all the documentation will be considering it, and it's a highly suggested first option. So this was an incredible announcement for developers. This has been something we've been begging for years, and when this announcement actually happened, everyone went ecstatic. It was amazing. This, like I said, in 2019 was concrete with this. that Kotlin was the preferred language of choice. This is amazing. It's an amazing choice, an amazing development in our environment. So we went a bit crazy. And this is also a major turning point in our architecture. So we sort of lost our shit a little bit. And we started seeing a lot of different changes in the way that we handle things. In terms of libraries, for example, now we saw this already happening with reactive Java, but then we started seeing it happen with Kotlin and with KTX functions. So we started seeing Kotlin libraries and Kotlin library wrappers, and then some more Kotlin libraries, and some more Kotlin libraries, and some more. I guess the thing you can take away from this is that developers really like build badges. More of a laugh. But this is all right. I'm okay with this. This is fine. When people are adopting Kotlin, we're seeing accelerated growth. This is a really kind of nice thing to see. So, it's maybe a bit of accelerated explosive growth, but it's okay. It's fine. So what makes Kotlin so elusive, really? What makes us all want to jump on this bandwagon? And as I said, it's the idiomacy of it. This isn't to be confused with the 2006 film Idiocracy. This is idiomatic code. What is the definition of idiomatic? So this is using, in the terms of language, it's using containing or denoting expressions that are natural to a native speaker or a native reader. So you're using the benefit of the language in its purposely environment. So there we go. When it's in program languages, it means that you're using the features of the language in places that actually make sense, which are consistent with the behavioral expectation of that language. So you're using the functions available to you to make your code more appropriate. So Kotlin has very many different idioms. There's a link at the bottom, which you probably absolutely cannot read, but I will share the slides at the end, and you'll be able to check them out later. So idiomatic code is sort of less ambiguous for new contributors. You have a consistent, easier to read contributions. You have less cognitive load, which is really quite important. It means cognitive load is when you're looking at something and how quickly and easily you can understand what's going on. So maybe it takes you 20 seconds to look at a snippet and then think, oh, now I know what's going on. But then you have a more concise example which has less lines of code and it's much more clear. That has less cognitive load. There's less ambiguity. It's much clearer what's going on, therefore contributing to cognitive load. And you have function over style, so it's more pragmatic. You have aesthetic code as well, and you do have both, but it's function over style, function over, yeah. So JetBrains and Google both define a common code style. This is one from Kotlin Lang, and this one from Android, or from Google, sorry. And these sort of suggestions on how to structure your code in a kind of architectural way, not architectural way, sorry, in a sort of ordering pattern. So how does this actually relate to refactoring legacy code? And how can I start kind of converting my Kotlin code to my Java code to Kotlin? Well, there's one simple shortcut for this. Job done. It's too fast. Job done. We can go home. All of our code is converted. Everything's fine. Mic drop. But no, don't do this. It's not great. But why, you might ask? Why shouldn't we use this built-in tool from JetBrains and Google to help us kind of bridge this gap? If there's something there that is an opinionated behavior, then why shouldn't we use it? What's wrong with this beautiful shortcut that fixes all of our problems? Well, let's take an example. Now, this is a bad Java activity, and we have an injected dependency. It doesn't matter what sort of dependency injection framework we're using, but we're using the JSR 330 specification to inject a dependency. Now, when converting this, there's a lot of assumptions that are made, and there's a lot of general assumptions. So for example, converting it straight over, then you would get something like this. Now, the converter doesn't really know where it should apply internal, because internal doesn't really exist in the Java world. So how should it know if it should be public or internal, or how it's accessed? Maybe you wanted it as public, maybe it should be private, otherwise. And it also doesn't know about nullability. It doesn't know whether it should be null if it's set later, because there's no annotation on the Java implementation saying it's not null. So it makes assumptions about these, and then you end up with this kind of very, very defensive, safe code that has a nullable dependency that is assigned to null and is public. And let's not forget as well, it is mutable when it need not necessarily be. So this means you actually, when you try and access this, then you have to apply the double bang to force it into not nullable state. It's not ideal. So we had the internal latent in it, and this makes sure that it's no longer nullable. So stepping in the right direction, getting there a little bit. Still needs to be var because you're still actually changing the property of it after its instantiation. But you're saying that it's late in it. And when you try and access this, if it's not been injected, then you'll get a uninitialized property exception. Quite similar to a null pointer exception, but still not ideal. You can also check if this property has been initialized with this kind of double colon file that is initialized. At this point, you're sort of not much different from just setting a nullable var, so you have to kind of pick which situation fits you best. But yeah, back onto then nullability then. So what's the difference? What's the benefit there? I need a new pointer. So back to our $1 million mistake. If we have to access all these nullable properties, then we have to use this double bang operator. And this is what's going to happen in your code if you directly convert using this shortcut, is that every access to this property that is now mutable and nullable will be accessed with a double bang operator, and littering this all around your code and becoming quite ugly and not having this terse, idiomatic, lovely Kotlin code that we were all promised. But it does ensure the same behavior. So that's sort of what we want to do with an automatic conversion, really. We don't want to have assumptions made and then end up having breaking behavior because, well, that's not really the point of the tool. So let's take an example. So we have a my_null_val in Java, and we access this from we access my method on this property. Now this throws a null pointer exception. Not ideal. We convert this to Kotlin, and we have the double bang. Still throws a null pointer exception. So at least we have the same behavior. That's something, right? Well, we could also use the question mark operator, so the nullable operator, to say, only execute this if it's not null. And instead of an exception, we just get nothing. Nothing happens. Okay, but we've still got defensive code then. We don't know the behavior of this at compile time. We don't know easily what we can test here. So, well, let's compare this to another one as well. So then we could just have this lovely scope operator. Yay, Kotlin scopes. We should all use them. Yeah. It's really highly defensive. And not only is it highly defensive, this is actually a language abuse. Because you're not handling the failure situation. You're just kind of blindly saying, oh, I don't care if it's null or not. Just execute this in a successful environment. So it's really defensive code. So you're going to end up in situations where your application is not predictable. It's not doing what it should. So you're not handling this error. You're not giving this information to the user. An ideal situation is you want to have this information given to the user saying, hey, an error happened. What can I do about it? If it's a recoverable failure, for example, maybe the user was going through a tunnel and they lost their internet and you want to be able to give them the opportunity to retry. There's always a good reason to use this to your advantage to have a failure resolution case. So let's bring back our offensive code. So, the double bang operator, this ensures the same behavior. It's considered offensive because it will fail fast. It will fail as soon as this property is accessed. But, you might say, oh, the double bang operator, it's ew, icky, I don't want to have it. So what else could you do? Well, you can have this require not null property method, and it'll give you a legal argument exception with required property was null. Okay, so it's a bit of an improvement. It's still not ideal, but we're crashing first, and we're getting a more helpful message than an MPE. But we can do a little bit better than this. we can actually use this to provide a custom error message to give some informative feedback. So when you're looking at these crashes in your crash reporting tool, you can see, oh, there's a reason why this crashed. There's a reason why this was null. So this means that you are failing first, your code is offensive, it is predictable, and it is failing at the point of the error. So you can easily test it and find out what's going on. It's really much more informative. And you can even make this much more better as well. So for example, you want to have your own impossible exception, something that shouldn't ever happen. And with this custom exception, you could then use the Elvis operator to then throw an impossible exception if this property was null. And therefore you have a private backed field that is no longer null, or no longer nullable. So you then have made this assumption clear and stated that it's not null, can't be null, not going to happen. And then you can go even further. So this kind of impossible exception, you could have additional behavior. You could have some catching things on it. So you could have like a nice kind of clear error message that makes us all quite sad. But you can also add behaviors and kind of recovery behaviors. I think there's the recoverable exception in the GMS library. This is from the XKCD comic recently, unreachable point. Made me laugh. But the point is here that you can use exceptions to your advantage, and you can provide fallback behavior. You can provide much more informative messages and help out your user. And help out yourself. Because if you're going through crash logs and you have no idea why this error is being reported here, then it's just going to drive you insane. So what else can we use in Kotlin? Not just exceptions. We've got our favorite data classes. Now, data classes are amazing. It's one of the most exciting things about Kotlin when you start moving from Java. And this is because you're probably familiar with the Java beans that we have, well, we used to have anyway, these Java POJO objects. Now, you definitely can't read this, but I don't think you need to. It's a POJO with a couple of properties that represents a user. It has only two properties, the first name and last name. But because of this POJO behavior, you have the getters, you have the setters, you have the equals method, you have the hash code method, and you have your constructor. So it's really verbose and really hard to read code. Now, perhaps in some situations you can have this automatically generated. Perhaps you could use an annotation processor. But with Kotlin, we get the access to data classes, which makes it much, much nicer. So direct conversion using the command Shift Alt and K gives us this little beauty, which is not much better, really, because this is just a manual implementation of this class. And that's because the Kotlin compiler can't really make an assumption about the implementation of your equals or hash code. Perhaps you made a mistake. Perhaps if then Kotlin makes an assumed implementation of your equals method, that might actually end up breaking your code. So it has to preserve the existing behavior that is already there. So then, therefore, it uses the existing equals and the existing hash code, but then changes these properties to in the constructor declaration here. But they're still mutable and they're still nullable. So we can improve on this, right? Much better. This one data word implements all that for us. And now we get the immutable objects. These properties are not immutable, so they're not nullable. You can access them safely and easily. And the equals and hash code implementations are provided for you. Sweet! But what if you need it to be null? What if the user is Cher and they have no surname? Well, you can reintroduce nullability if it's required, and then provide a default value if you need to. And the nicest thing about data classes is that you get this free kind of copy method where you can then kind of create a new object, because if it's immutable, then you can't really do much with it. So you can then create a new object providing new values, and using default parameters with Kotlin, you can say what values I actually want to change. This removes a lot of necessity for builders and factory patterns in your code, since it's not really much necessary anymore, but it doesn't stop you from using them. You can still have builders, still have factories if you really want to, but in most cases you're not going to need to. What other Kotlin idioms do you have then, like what we can use to our advantage? So have things like singleton objects. If you're aware of the singleton pattern already, this is when you have a static instance of a class which is initialized on first access. and then it's like the same instance guaranteed throughout the same entire class path. This is provided by singleton objects, so if you have an object in Kotlin, then that will be the same object that you'll always return. Has the limitations, you can't use generics, you can't have constructor instantiation, but still you can have the same behavior. Things like string interpolation, this is really nice, where you can actually have a parameter inside a string without having to escape the string or escape the parameter inside, and you can have like small little execution blocks as well. I'm going to be here all day. So you have the Elvis operator as well. So I showed you earlier with the accessing of a nullable type and then creating a non-null value and then throwing an exception that might give you feedback. This is using the Elvis operator. So it's basically saying if this is null, do this instead. Now you can use this to provide default values if your parameter is null. It's really useful in providing this kind of individual terse syntax. I think you can probably have a custom font that would actually change the Elvis operator to this little dance emoji, which would be amazing. Deconstructing as well. This is actually really quite cool because each element in a data class is represented by a component. So then you can say component 1, 2, and 3 is these 2 or 3 parameters in your syntax. Unfortunately, I can't show you an example here, but it's great. Extension functions. We all have extension functions. Who's using extension functions? Who's not using extension functions? What's wrong with you? But the thing with the extension functions is you sort of have to be a little bit careful because it really is easy to pollute your global namespace. I recommend taking a standardized approach with extension functions, that if you want to make a top-level extension function in the global namespace, keep it localized to a package so that they're easy to kind of identify and easy to find and manage if you need to. If you're just defining them anywhere, everywhere, a lot of places, you'll find that your IDE will start suggesting things that necessarily aren't really what you want, and you don't want to have them scoped the entire global scope. So keep them narrow, keep them private if possible, and if not possible to keep it private, keep it internal. But if you really want to make it public, make it manageable. And scoping functions. So I showed the example of the apply earlier. This is when you can then provide a execution block on an existing project, an existing member. This is quite nice because you can then kind of couple syntax into a chain method chain, which is quite nice. You can also see there's a link to the rest of the idioms at the Kotlin Lang documentation. Again, slides will be provided at the end, so you'll be able to check these out later. So one of the questions I often received when asking people what they wanted to hear, like how to refactor your legacy code, is how to maintain your history. Now this is a really interesting one because people just want to sort of migrate in one step to a Kotlin class, and it can actually be quite troublesome because if you migrate everything over to one class or like several classes, then you're immediately losing that Git history. Because everything's been lost, all the changes that have been gathered over time, all these little hot fixes that you've had to do, all this information and pertinent history about your classes is then just lost. So it's really important to us to kind of retain and keep this Git history that is important for your class. So, I'll wait. So how could you do this? If you really wanted to kind of maintain your history by using this whilst using the command Shift-Alt-K conversion, you can, you change the extension of the class so that it's a Java class. It will no longer compile with this, and you commit this. Then you apply the Kotlin conversion to it. You'll have to change it back to a Java class first, but then you commit that. You have to make sure that you're not using squash commits with this case. There have to be separate commits in your main master history for this to be represented. But at the same time, it's still not really going to work because you've still got a mass conversion of the entire file. What if it's a large file with different hotfixes, different kind of changes and behaviors that have happened over time? This information is still going to be lost, even if you can track it down to a single conversion commit. So I find the best way to actually refactor into legacy code is actually refactoring itself. So taking a look at the behavior of a class, analyzing what it's doing, really understanding the business value for it, and then abstracting that. Since most of the time, when you're refactoring code, you will find that it's actually a violation of single responsibility. Your Java code is doing way too much. And there's always, always, always an opportunity to extract this into a new class or new implementation, which is further easily unit testable. therefore making Mr. Michael Feathers happier. So you should already be familiar with solid design patterns. Everyone here is familiar with solid design patterns? Hands up if you're not familiar. Okay, cool. I'll just cover it quickly so that you can get an idea for it. So it's a concept of 5 principles that are all named as such. So it's a core 5 principles that are named as such so that we can have a nice acronym. So we have the single responsibility principle. This is the idea that something should only do one thing at a time, or one thing, one responsibility. You have the open-close principle. This is that you shouldn't, have to kind of change implementation to add a new behavior, so you can extend that. The common comparison is that you shouldn't have to perform brain surgery to change somebody's hat. Other one is Liskov substitution principle, which is that an interface can be swapped out for another one. It's pretty much just called this so that they could have an L in the middle. Interface segregation. This is that you shouldn't have to implement all of the parameters, all of the methods on an interface if you only need to require one behavior. So your interfaces should have single responsibility. And finally, dependency inversion. And this is when you make sure that your implementation doesn't require a specific implementation of another one, but this can be abstracted through an interface. And remember, if you're doing all these, then Uncle Bob will be happy, but remember, if you're not, then Uncle Bob is watching you. So Uncle Bob is accredited as the author of the Solid Design Principles and the Clean Coder Handbook. This is a good read. But essentially, you don't really have to worry about all these, because generally they all kind of just boil down to the same single responsibility principle. And now if you remember this one, then you're generally just going to be fine with everything else, because everything that I've mentioned is sort of the same idea about the single responsibility. Interface segregation is still about having the interface doing one thing. Dependency inversion is having this interface that only does one thing provided to you to do one thing. Open-close principle, if you're only doing one thing, then you don't need to change it. So it's basically the only one you need to really remember. And it's really important when you come into Java classes, because you'll often find that your Java classes are doing too much. So you find which responsibilities this class has, and how can I abstract that? And the nicest thing as well is that it gives you a really fresh perspective on what you're doing, because you have to understand and analyze what's going on in your code to be able to kind of then change it. You have to have it tested as well. So this is the book I mentioned earlier with the Working Effectively with Legacy Code, where you can learn how to apply seams, how to sort of abstract and move away behavior, so then these new behaviors can become testable. And this is the same sort of reason to kind of redo code and re-understand it, the same reason we do our kata exercises. So we can hone our skills, we can get a little bit better every time. And the nicest thing about Kotlin as well is that it kind of discourages the uses of static. So when you have a static implementation inside of a method block, then that's really difficult to test. But since this doesn't really exist in the same way, you have to kind of think about the implementation, and then you're therefore automatically applying dependency inversion. So this is a really nice thing to do. And one of the really nicest places I've actually found this to happen is with coroutines. Now, asynchronicity is, well, we have it in every app. Everything is asynchronous, essentially. And you have it in situations where a method doesn't return a value immediately. It may do a little bit of computation, it may need to make a network request, but it has to do something in the background and then bring you back a value. Now this is extremely important in UI-dependent environments, especially with Android, because we can't block the UI thread whilst we wait for the network operation to happen. The user's going to get quite frustrated. So concurrency is hard. When you're managing multiple threads and different processes, you can often end up with race conditions and different sort of issues like this. You might be familiar with the basic way of operating a thread in Android and Java. It's a simple new thread foo start. It's the simplest of operations, not very efficient, and it's quite resource intensive. The result isn't encapsulated, so all of your operations are happening inside this Lambda block, and then you have to mutate your state around it. So it's not quite effective. In Java, you also have the computable future. This is not available on Android. This is just one of the kind of back-end terms. We have an async operation, and then you might have this chain, like you do this, then this, and this. And then you might have Rx Java. Has anybody seen an Rx Java chain, anything like this? Has anybody written an RX chain like this? Because I would just like to assure you that this is definitely not an actual code example from an actual code, from an actual application, from an actual person in this room. Promise. But you can see how that escalated quickly. It got quickly out of hand. So what if you can write code sort of sequentially in this sort of pattern? You can write asynchronous code as though it were imperative. Well, that's where coroutines comes in. Now, if you're not already familiar with coroutines, and you're not already familiar with my inability to damn slides, if you're not already familiar with coroutines, I really recommend you go checking them out. They were marked as stable in 1.3 in October 2018, which wasn't actually that long ago. They're available in other languages, and coroutines are basically, they've been around for a really long time. And the idea is that it's just a basic subroutine for a non-preemptive or cooperative task that you can make sure you're not blocking the main thread. And it means you can write code as though it were synchronous in an imperative fashion, but it will execute asynchronously. So consider the following code block. Now, you got this quite simple kind of global scope.launch, and we saw from the earlier presentation about live data scope and how these different things can integrate with lifecycle, but I'll just do a really high-level coverage here. Now it's sequential by default, and it's seemingly imperative. You've got your actual asynchronous operations happening here, so you're delaying this thread or this thread from executing for 1,000 milliseconds, which has to be called within a coroutine, so otherwise it will not compile. And then here we're using the global scope, which is basically just saying, this scope will exist for the lifetime of the application. I'm not really caring about what's going on. In ideal situations, you want to use a more refined scope that is closer to the life cycle of your current framework component. And scope can be created with dispatchers, so you can have your own dispatcher if you need. The stability of this. Now, if you're familiar with the release process of the Android X libraries, the postcursor to the actual, so the resulting of the support library components, you'll notice that these libraries are versioned independently as alpha, beta, and release candidate are then stable. And these can sometimes take quite a long time to actually release because you want to make sure that it's rock solid stable before it's actually available. But you still want to get feedback from it, so you still want to use it. But maybe you don't want to use alpha, so it prevents you from using any of the bug fixes that might have gone into this release, but then you're still waiting on it. So the difference with coroutines is that they're using annotations to denote the stability of the API. So you have stable components, which are the core fundamental parts of the API, and then parts that are kind of under development or still kind of undergoing development have this experimental tag at the end as well, annotation, sorry. And this is really nicely done because it marks different types of experimental. There are 3 different experimental annotations, denoting whether it's is it just experimental, or is it obsolete, or is it internal, or is it flow, or however. And the nice thing about this is actually you can use this annotation yourself to create annotations annotated with this annotation, to annotate your own annotations, to annotate the classes that are not annotations. Which is a really nice way of actually modeling your SDK API. Now, there's a really great talk from Yossi Wolf, he gave it to Kotlin Hamburg. The slides are available online. I've got the link at the bottom there. And he talks about how to use this experimental annotation to mark parts of your SDK which are undergoing development, and then you can use that as documentation when you're providing an API, for example. And it's really, really, really useful. So back to coroutines. What makes coroutines so great? Why is everyone so happy to use these? Well, it's a native library, and it's provided native support from JetBrains. So it's continued evolution, continued progression of this language structure that we're all so familiar with. And it's got everything that's already awesome about Kotlin, but then provided with a library, and it's not reliant on a third-party implementation like RX or otherwise. It's really, really remarkably efficient. Uses threads really efficiently, and I think you can fire up to like 100,000 threads sleeping without any kind of performance hit, and it's quite surprising. It's really easy to use, as you saw from the previous example. Learning curve is quite kind of straightforward to get onto. And if you want to have a suspended function or an asynchronous behavior, you simply just have a suspended fun. This one suspend operator is enough to say this operation should be a coroutine. And that's it. That's all you have to do. And this really comes into play when you're working with asynchronous operations, because then you can have a method that actually returns a value. So let's look at our previous example. And we take our suspended operation. And say if we want to, we want to abstract this into a new function. So then by abstracting it into a new function, we could then abstract it into a new class. That new class is testable, and it's much more easy to use. And then we are refactoring legacy code. Well, it might look like this. In this new method here, in doWorld, we have its own testable behavior separated. And because we're using the suspend fun, we're using the suspend operator, we're saying that this individual operation should be asynchronous. But what if perhaps we need to use our own scheduler? Well, you just say with context, and then you can change that. I wouldn't recommend using this statically. You can always have injected dispatchers, or you can use the test context. But the best option is to actually inject it. You can see a really great example on this from the Plaid library, Plaid application. What does this look like in testing as well? So if you have suspended functions, you simply just have to run blocking test. And then this builds you a coroutine context where you can execute all these different suspended operations in the test environment. And it's really great because this run blocking test will give you auto-advanced operations. So say, for example, you have this sleep thing, and it's kind of you're blocking your thread there. It will be auto-advanced, and you can actually test this reliably. So that's sort of bringing everything to a close, thankfully. I'm sure you're all quite tired. There's some further reading, which is really great to go through. There's the Google Code Lab through refactoring to Kotlin, which I unashamedly stole a few examples from. There's the Kotlin X coroutine test library. This is really cool if you're using coroutines and you want to use testability. It has a lot of the concepts of using this kind of test coroutine scheduler, test coroutines context, where you can advance the timer so that you can say that something should have happened in X amount of milliseconds, and I want to assert that behavior. There's also the coroutines plus testing talk from Sean. This is a really, really great talk. He gave it in Berlin this year. This year. Highly recommended. This is another talk from someone else I know. This is on comparing RX Java behavior and coroutines. Sometimes you want to migrate from using RX and using something simpler in coroutines. And the nicest thing about this is that you really have to understand the fundamental behavior of the component. You have to kind of understand the business behavior. And by having that better understanding of what's going on, you have the ability to actually apply further testing. You're resolving legacy code by making it no longer legacy. It's tested code. It has automated regression testing. So you have refactored your legacy code into testable, reliable Kotlin code. And that's everything. Thanks. So the slides are available here, bit.ly refactoring legacy code. You can find all the links and things I mentioned during the talk. Wait a second. And so yeah, I'm going to try the questions thing. So I put this link at the beginning. And it's my first time trying this, so let's see if it works. Well, actually, it doesn't matter since there's no questions. Does anybody have any questions now, then?
I'm going to ask something. So you said, for example, you have legacy code.
Mm-hmm.
What happens if it doesn't have any test coverage? Do you try to test that in Java and then try to convert it to Kotlin? Or how do you manage untestable or untested code?
Well, this is one of the nice concepts that's mentioned in the book from Michael Feathers, where he says, there's code that's not tested. I can't reliably change it without, being uncertain about the impact of that, whether it might have regression issues. So there's lots of different mechanisms where you can sort of move code around a little bit without affecting its behavior. So you could start just kind of abstracting things into new methods. But the basic concept is creating seams between different execution paths. And by creating seams in these execution paths, you can in most situations, actually extract that behavior. So then you could, if you wanted to have an extra step in this situation, you could have this seam creation, you abstract this behavior into a new Java class, where it's single responsibility. You can then reliably assert behavior on that. You have some unit tests on that, and then migrate to Kotlin. But because you're migrating in small modules, you're not actually polluting your Git history with all these kind of mass migration things. You actually have purposeful individual changes. So it's much easier in a historical type of fashion. Hope that's enough. Cool. Then let's enjoy beer. Thanks, everyone.